Alright, so I think I've got this set up. How's everybody doing today? In this video, I'm going to give you a brief little overview on how you can use Excel to calculate the standard deviation of both a population and a sample. And there's two formulas that we're gonna sort of explore today. The first one is this one right here. Essentially, this is the measure of dispersion or the standard deviation for a population. And the way we calculate the standard deviation of a population using this formula, you're going to start by taking the difference of the observational value and the mean, and then you're going to square that. And then once you have all of those different squares, you're going to take the sum, and then you're going to divide it by the number of observations in the set. And then the second formula that we're going to use that should result in the same answer is this standard deviation formula right here. And essentially, we take the square root of all of the, we're going to square all of the x values or all the observational values, take the sum of all those values, and then we're going to find the difference of that in the quotient of the sum of all of the observational values squared divided by the number of observations in the population, and then we're going to divide that by the number of elements in the observation in the population. So let's start by just jumping into this situation here. So this example is pulled from one of the examples that I use in class, and essentially we're going to be calculating the standard deviation of travel time. So here our observational x column travel time is in minutes, so 23, 36, so on and so forth. The first thing we want to do is we want to calculate the mean. So if we're doing that in Excel, we're going to highlight all of the cells that contain our observational values, and we're going to go to this auto sum option up here. And this is where we're going to click the average. Now when we're working with statistics, we're not calling the mean average, but that's just the notation that Excel uses. Alright, so let me clean this up a little bit. I'm going to go here and I'm going to reduce to the hundredths place just for the time being. Okay, so that's our mean. And then n represents the number of observations in the set, so we just go ahead and count them. And this is a population, remember. So 1, 2, 3, 4, 5, 6, 7. So in this case, n is going to be 7. I'm just going to leave this formula up here so you can see it a little bit better. Okay, now when we write functions in Excel, we want to start by clicking the equal button. And then what we're going to do is we're going to click the cell that we want to use first. In this case, our first x value is going to be 23, so we're going to click on the cell B3. And now our operation is subtraction, so we're going to hit the subtraction symbol, and then we're going to click on our mean down here. Now, one thing I'm going to show you this process in a second, so that's going to be C, not C, that's going to be B10. So you can type it in and do it like that as well. So one trick in Excel, you can go ahead and drag this down here. But as you drag, it's going to increase your B column. But sometimes, I'm sitting here pointing at the screen like you can see it, sometimes it's also going to move the second value down. So it'll be B10, B11, B12. And if we click here, we can see that in action. So we're going to go ahead and undo that. And here's a little trick with Excel. If you want to keep your second cell the same, what we're going to do is we're going to go and we're going to put a money symbol or a dollar symbol in between the letter and the number. Because if we do that, then as we slide this down, the B cells, the first cells will change, B4, B5, B6, 7, 8, 9, 10, which accounts, or 9, which accounts for all of these cells here. If you look, the B10 cell remains there. So if we want that second cell to remain stagnant, just put a dollar sign between the letter and the number, and that'll be exactly what you need. And then here, we're going to square the difference of the observational value and the mean. And so there may be a special function that you can use in Excel to square values, and it could be something as a simple notation. But we know that when we square a number, we're essentially multiplying it by itself. So in this case, we're going to multiply the cells by themselves. And then the same trick, click on the lower right hand, and then we can go ahead and slide that down. And then let's go ahead and reduce the number of decimals that we have for right now. So if we go back and look at this formula, we almost have everything that we need. the last thing we need to do is we need to take the sum of this column right here. So we're going to do that by going to this auto sum option and then click sum. So if we look at this formula on the PowerPoint slide, we have the x minus, or the observational value x minus your mean all squared. That's represented in this column here. This summation notation just means we want to add up all of those elements, which we have here. So we can go ahead and label this sum. Now, the next thing we need to do, and the final thing, we need to take our standard deviation, which is going to be equal to the square root. So we're going to type in sqrt as our square root function, and then we're going to put our parenthesis there. So we're taking the square root of this value, which is the sum of all your x minus your means squared, and then we're going to divide that by the number of elements in this population. In this case, we have this value right here. So we now have a standard deviation of 11 and 36 hundredths. Now let's go ahead and try that with the second formula. So if we look at the second formula, we first need to find the sum of all of the x squareds. So what we're going to do is we're going to type in a function equals this cell times this cell. So the 23 squared is 529. And if we drag this down, it's going to calculate the squares of every single individual cell here. Now we need to take the summation of that, so we're going to highlight all of these and click this right here, and then our sum is going to be 5,228. So that represents this piece right here. Now what we also need to do is identify our n. N is 7. So in addition to that, we also need to find the sum of all of our x values. And we're going to do that by highlighting all of our x values in this column and clicking the sum. Now, after we've found the sum of all of the x values, we need to square them. So the sum of all of the x squareds is that value. Oops. I'm just going to type that in. So 5,228. And then the sum of all of the x values squared is going to be equal to the sum of all of the x values. I want to see if this works. I don't know if that is the right thing, so let's check that out. Oops. 10. Alright, so that actually worked out pretty well. Okay, so we have some work to do here. So if we want to construct our equation, it's actually going to be equal to, we're going to keep the square root function, square root, and then we're going to have to build some numerators here. So this is where it could get a little bit messy, so we're going to figure that out in a second. So instead of trying to type all of this into one cell, I'm actually going to take this value here, the sum of all your x squareds, and I'm actually going to divide that. So, oops, let me get out of here for a second. So one thing that you want to be careful when you're working with Excel, if you start a function, it's probably going to keep that function going. Make sure to clear out your equal sign before you click any places on this on the screen. So here we have this summation here divided by the number of observations. So we have 30,276 divided by 7. It's going to give us this value right here. So in order to calculate the standard deviation, we have to take each of these individual values, or these individual terms which we've identified here. So we're going to have the square root parenthesis of the, and I'm going to add a second set of parentheses because I want to enclose the numerator values, the terms in the numerator in a set of parentheses, just to make sure that the order of operations are going through correctly. So we're going to take the sum of all of the x squares, which is 5,228, minus the sum of all of the x's squared divided by 7, which is this value right here. Close that parenthesis and then divide by 7. And if you look, the parentheses are in red, which means that we might have some issues here. So something pretty cool happens. So if we look at the standard deviation that we calculated with the first formula, it's actually equivalent to the standard deviation of the second formula, which means that we actually did our work correctly. So despite all of the difficulties that may have occurred with using Excel, we can just unpack things piece by piece, and we can use Excel functions to do this work. Now, the standard deviation of the sample is going to be very similar, except for the fact instead of dividing by n, we're going to divide by n minus 1, which is a degree of freedom. So in this case, n is equal to 3. So n minus 1 is equal to 2. So we're going to use that value instead of n as our denominator. So if we look here, we have to set up the equation the same way as we would have with the population. We're going to start by taking the mean of the sample, which is going to be close but not the same as the mean of the population. And then the process is going to stay the same, so we're going to take the difference between our observational value and our mean. And again, we want to keep that mean value consistent, so we're going to put the money sign between the letter and the number. And then we're going to go ahead and drag this down here. So that's your x minus your mu. And in this case, it's actually not mu, it's going to be x bar, because we're dealing with a sample set. So I just copied and pasted it, and I shouldn't have done that. Here we're going to square our x minus our x bar. So the same process as before. You're going to multiply the cells together, and then you're going to drag it down. Now we have all of that information, and then the last thing we need to do is take the sum of these values to give us the numerator value here. So now we have our numerator, we've calculated our numerator, which is essentially 502 thirds. And what we're going to do is we're going to take the square root of the numerator, which is going to be 502 thirds, and we're going to divide that by n minus 1, which is going to be 3. So the standard deviation of this sample set is 15 and 82 hundredths, which tells me that the standard deviation of this particular sample is a little bit larger than the standard deviation of the population, which means that data is spread out a little bit further away from the mean. But that's okay. All right, so let's finish up the video by looking at the second equation, which is going to be right here. So it's going to be very similar. The first thing we need to do is we need to square all of our observational values and all of our sample values, essentially. So we're going to take our formula, we're going to type in cell I-28 times I-28, which is this cell right here. And then once we do that, we can drag this corner down and it'll fill in the rest of those boxes. And then what we want to do is we want to take the sum of all of those values, which is going to give you 1997, which is going to give you this term right here. Similarly, we need to take the sum of all of the x's, because what we're going to do is we're going to take the sum of all the x's, which is 67, and we're going to square it, because that's going to give us the numerator here of this particular quotient. And then we also need to take the sum of all of the x squareds, which we did that already, silly me, 1997. And then we might just want to make this sum of the x's squared divided by n a little bit neater. So we could say sum of all of the x's squared, and then we could write in divide by 7 or divide by 2, and we could say n minus 1 because that's what we're working with here because it's a sample. So we're going to take the 4,489 and we're going to divide that by 2, which gives us a value that might not actually make sense. So let me go back here and backtrack real quick. So we got 67 squared. Make sure I got the right value. So 67 times 67. Okay. Minus n. Oh, so I made a mistake here because we're going to divide by, I don't know why that zoomed in like that. I mistyped that formula. So I was toggling back and forth on my screen. It's actually the numerator here. We're not dividing by degrees of freedom. We're actually dividing by n. So in this case, it's going to be 3. And the reason why I picked up on that being an issue is because I noticed that this second term here was going to be larger than the first term, which would result in a negative radicand. And that wouldn't be good because that would give us a complex root, which doesn't match what we originally found. All right, so now that I've got that term squared away, we can set up our standard deviation, which is equal to the square root parenthesis. Remember, we're going to do 2 parentheses because we want to account for this numerator. So the sum of all of the x squared is going to be 1997 minus the sum of all of these squares here, sum of all the x values squared divided by n, which is this one right here. And then we're going to divide that by our degrees of freedom, which is 2. Okay. Now, if we zoom out, I don't want to delete that. I just want to zoom out a little bit. View, zoom to 125. All right, let's see what we got. So if we look here and we reduce the number of decimals, it actually works out perfectly. So despite that one little faux pas here, I think that was a really solid approach, and hopefully this explanation of these 2 formulas will be helpful as you do this work. If you have any questions, please don't hesitate to reach out. I will be happy to answer your comments here on YouTube, or if you want to message me, if you're in my class and you want to message me directly, that's fine too. Anyway, hopefully this was helpful. I look forward to your feedback, and let me know if there's anything else I can do to support you.